Dear students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is the conversion of exponential equations to logarithmic form, and in our today's session we will be having the exponential equations containing variables along with some numbers. We have already had one session previously on this same topic, but over there the exponential equations contained only numbers, but in this session they will be containing both the variables and the numbers. Okay, so without any further delay, let us start with our today's session. First of all, let me remind you that we are reading the exponential equations in this form, the BPA form, where B stands for the base. We always read from left to right, and B stands for the base, P is the power, and E is the answer. To logarithmic form, which is BAP, where B is the base remains the same. The answer gets converted to the argument and the power gets converted to the product, which means the result. Okay. Now let us come to the rules. Rule number 1, keep the exponential function. Again, I have used this word function. You may read it as the exponential term, the term containing the power, on the left hand side of the equal to sign. Now this is not a compulsory step. I am assuming that you are totally a beginner to this chapter on logarithms, so you do not know how to convert exponential equations to their corresponding logarithmic form. Therefore, I am just maintaining a general format. When you become an expert, you will be seeing that you will know which rules to be excluded when and which rules to be taken. Okay, so I'm assuming that you are new to this topic, therefore I have maintained a general format for every given question. Okay, so coming to rule number 2. Take the coefficient if not equal to 1 of the exponential, I'm reading it as the exponential term, to the other side. And how do we take the coefficient to the other side? We divide the entire equation by the coefficient. Okay. Rule number 3. Convert to the logarithmic equation using the BAP rule. The BAP is, as I have said, the base, argument and the product. And rule number 4, which is an optional rule, do not keep assert as the base in your final answer. And as I have written, this is an optional rule. If you think that you will be making some mistake while doing this step, just forget about this step. You will not be losing any marks if you just don't follow this step, or if you keep assert as the base of the logarithmic equation. You will not be losing any marks, but definitely you will be losing some marks if you do some mistake in the process of conversion, in the process of the omission of this cert form. Okay. So let us come to the questions. Write equivalent exponential statements for the following. Question number 1. Y equals 2 raised to the power of x plus 1. Now you see, y is a variable, x is a variable, and 2 is a number, y is a number. So you are having both the numbers and the variables in this session. Okay. And this is an exponential equation which has to be converted to its corresponding logarithmic form. And the rule number 1 says we have to write the exponential term on the left hand side of the equal to sign. So we rewrite this equation in this form: 2 raised to the power of x plus 1 equal to y, where 2 is the base, x plus 1 is the power, and y is the answer, BPA. And we have to convert it to BAP, where B is the same base. So it will be starting with this word log, because it is a logarithmic equation. It will be starting with this word log. The base is 2, which is the subscript. The product sorry, this is not the product, this is the answer. Answer becomes the argument. So it is log of y to the base 2 equal to the power becomes the product or the result. This is the only one that is remaining, so it has to come to the opposite side of the equal to sign. So this is log of y to the base 2 equal to x plus 1, which is the corresponding logarithmic equation or logarithmic version of this exponential equation y equal to 2 raised to the power of x plus 1. Okay, coming to question number 2. Square root of k raised to the power of x equal to y. This time the term containing the power is on the left hand side of the equal to sign, so we do not have to change the sides. And for rule number 2, the coefficient is equal to 1. Even for the first case, the coefficient was equal to 1. It was 1 times 2 to the power of x plus 1. Even in this case, it is 1 times square root of k to the power of x. So we have nothing to do for rule number 2 as well. Coming straight to rule number 3, and root or square root of k is the base this time, and x is the power, and y is the answer. So converting it to the logarithmic form, we have, it starts with log. The base remains the base, it is the subscript. The answer becomes the argument. So it is log of y to the base of root k. And what is remaining? This is the power is remaining. So it will be coming to the opposite side of the equal to sign. So this is equal to x. Log of y to the base square root of k equal to x. And in case you want to apply the rule number 4, you just want to get rid of the third form in the base, you can do it by rewriting the original given exponential equation in this form. You do the square, or you take the square of both the sides. Squaring both the sides, we get k raised to the power of x equal to y raised to the power of 2. And now we have got rid of the square root part. So k is the base, x is the power, and y squared or y raised to the power of 2 is the answer. This equation is our original equation. It is not the original given equation, but we are assuming this to be our original equation, exponential equation, and we will be changing this equation to its corresponding logarithmic form. Okay, so the base will remain the base. Base is k, so log of to the base k, and log of, this is the answer, which becomes the argument. So it is log of y raised to the power of 2 to the base k equal to, the power comes down on the opposite side of the equal to sign. This becomes the product or result. So it is log of y raised to the power of 2 to the base k equal to x. Okay, and again I am repeating, if you think that you cannot do this step, you just be contented with this form. This is a perfect correct logarithmic statement or logarithmic equation. Okay, you may very well be satisfied with this. It only doesn't look nice. It is not that it is wrong. Okay, it doesn't look nice. That is the only thing. Okay, so let us come to question number 3. R times x is to the power of t equal to q. Now over here is to the power of t is the part which is containing the power, and now r is a variable. R can be equal to 1, but it can have some other value also. So now we use this rule number 2. Take the coefficient, if not equal to 1, of the exponential function to the other side. R can have a value of 1. Since it is a variable, we do not know what is the value of r, but it can have some other value as well. So we will be dividing the entire equation by r to take this r to the other side of the equal to sign. So we get this equation written in this form: s to the power of t equal to q over r. Okay, if we divide the entire equation by r, the r of the numerator and the r of the denominator of the left hand side cancel each other, and we will be having q over r on the right hand side. Okay, and now s is the base, t is the power, and q over r is the answer. Okay, so we will be using the BAP rule. The base remains the base, so it is log, and the base is s. The answer becomes the argument, which is q over r, so it is log of q over r to the base s, equal to the power comes down as the product equal to t. And we have not learned about the properties of logarithm, so this can be written as log of q to the base s minus log of r to the base s equal to t. But if you keep it in this form, even this is a perfectly valid logarithmic equation. Okay, so I have kept it in this form because we have not learned the properties of logarithm till now. Okay, so students, that was all for our today's session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.